In example 2, our job is to determine the coordinates for a point on the unit circle that defines the following angle. Draw a sketch of each situation showing the angle, point, and arc. All right, my angle is going to be pi fourths. Okay. All right, so if the angle is pi fourths, I know I'm at 0, pi halves, pi fourths. So on the unit circle, let's say that would be pi fourths as an angle. So I have the arc, and I have the angle. The angle is pi fourths. And then I know the point, since this one is on the unit circle, is square root of 2 over 2. This is one of the ones we memorized, square root of 2 over 2. Okay, so we have determine the coordinates and the point. We got the coordinates of the point in the unit circle that satisfies the following angle, and we drew a sketch of the situation showing the angle, the point, and the arc. Remember that arc is also a length of pi fourths as well. All right, now this one's going to be a lot trickier because this decimal is not on the unit circle. So it's not one of the values that's already on it. So instead, let me grab a calculator. Okay, and so I need to figure out about how big that is. So the first thing that I want to know is about how big pi halves is. So pi halves is 1.5, so I know that 0.4 is much smaller than that. Let's see if it's smaller than pi fourths. Yes, it's smaller than pi fourths. Okay, so what I'm trying next is, I know that pi fourths is a quarter, so it's halfway between there and pi halves, so it's a quarter of the top half of the circle. So maybe I'll try pi eighths, see if I can bisect that and see if we're getting closer, so I know about where to draw that angle. So let's try pi eighths. We're getting close, right? 0.3, 0.4, so I'm going to draw something that would look similar to that. Okay, so back over to my picture. If I eyeball out where pi fourths would be, I can eyeball out where half of that, where pi eighths might be, and that's going to get me close. All right. So on the unit circle, if, again, when I drew my scale, I was assuming that my radius was 1 to the point on the arc that I drew. So I'm going to draw an arc of a circle where up to the arc is 1, and then the angle here is the angle, I'm going to arrow it in, is the angle 0.41152, and that arc length right there as well is also a distance arc length of 0.41152. All right, now I need to figure out what the x and y coordinates are. So I'm going to find the sine and cosine of that angle to get the ordered pair. I can't do this in the unit circle, so I'm going to grab my calculator again, and we're going to do let's do the cosine first, since that's the x coordinate. So the cosine of 0.41152. So I'm going to write down an ordered pair that is 0.9165, comma, and then the sine value, sine of, if I copy that number, the sine, oops, the decimal place didn't come down, so hold on. There we go. The sine is about 0.400. I'm going to write a couple zeros, but I can't round it to even 4 places. All right. So that would be our ordered pair for this one. And right above that, again, what we did, that was the cosine of 0.41152 right there, and then we did the sine of 0.41152. And so we were just forced to round right here because that angle, even though it's in radian measure, I know it's in radian measure, not degree measure, because it does not have a degree symbol. Oh no, let me double check that my decimals was in radians. It was. Okay. I had it in radians because I was using it for calculus earlier, so we're lucky that I did compute those correctly. They are in radians. if your decimals was in degrees, you would have gotten something very different. If I switch to degrees for a second, you're going to see how those change. Much different than they were before. So make sure you are in radians if you're going to be inputting something in radians. Same is true on your calculator. You may have to change the mode on your calculator into radians so that you could evaluate that one correctly. Good. Okay. Now, the last one, part C here, the angle is pi. All right, so you can look at your unit circle to figure out where pi is. Or I know that since 2 pi is a full circle circumference, pi is going to be half of it. So my arc is half of a circle. For this to be the angle pi, and then the length of that arc is exactly pi for a radius of 1 for the circle, because that would be the arc length, matching that circumference of half of the circle. All right, and then the point that defines it. Okay, so again, my radius is 1, so my radius is 1 right here, so over to the point -1, 0. So in this particular question, we were able to use the unit circle on A and C because those 2 points are on the unit circle. And then for part B, I had to be a little more creative, and I had to figure out what the cosine and sine of that angle was to get the ordered pairs to that point. Okay. Now in example 3, it says the following points are on the unit circle. When it's saying that they are in the unit circle, it doesn't mean that they're on the pretty portion of the unit circle. So it's saying that they're somewhere on the unit circle. So these are the ones that we memorize, but there are other points on this circle, of course, right? Like this is a point that's on the unit circle, and so is this. So the points that it's talking about in the next example are on it somewhere. They're just not the pretty points that we memorize. We're going to have to do some calculation for them. So there are more points, of course, on this circle that aren't the ones that we memorize because they are from isosceles or from equilateral triangles, the nice triangles. Okay, just to make that part clear before we get into example 3. So these are points on the unit circle, but they're not labeled on there because they're not going to be pretty points. That's okay. This one has an ordered pair, -3/4, comma, square root of 7 over 4. My job is to find the coordinates of the reflections across the x-axis, y-axis, and origin. Sure. Okay. So I'm going to draw in these points. So let me draw in the unit circle. That's a circle that has, a circle that has radius 1. And then just want to label this point first of all. So it is -3/4, comma, square root of 7 over 4. So this is the ordered pair, approximately -3/4, comma, square root of 7 over 4. So we're going to find each of the following. We want first to reflect it across the x-axis. So that's going to reflect it down here. So part I. In part I, if I go across the x-axis, we're going to have the same x value and a negative of the y value. So that'll be, close my parenthesis up there. So this point will be -3/4, comma, negative square root of 7 over 4. Then when I reflect it across the y-axis, part 2, this is going to have a positive x value. So it's going to be +3/4, comma, square root of 7 over 4. And then across the origin, we'll switch the sign of both. So this one's going to be +3/4 and a negative square root of 7 over 4. Okay. Now, the reason that we look at these reflections is that all 4 of these angles have the same reference angle. So if I was to draw in arcs, they should all have the same angle, reference angle. And so they have not the same sine and cosine value, but the same with a negative maybe added in per quadrant. Okay, so that makes them interesting. Let's look at the next one. All right, this ordered pair, negative square root of 3 over 2, comma, -1/2. So that's going to put us right here-ish. So the original point, negative square root of 3 over 2, comma, -1/2. and then the 3 reflections. So the first, across the x-axis for part I, is going to switch the sign of the x-coordinate. So that will be positive square root of 3 over 2, comma negative 1/2. Then across the y-axis for part 2 is going to have a positive x value and a negative y value. So positives, that's what I did up here, which is a mistake. So I have to have negative there, positive there, because we have a positive y and a negative x. This one has the positive x and the negative y. Sorry. Okay, hopefully that makes more sense now. And then finally, when I reflect across the origin, we are going to have 2 positives. So we have positive square root of 3 over 2, comma 1/2. Okay. And just a fun fact on this one, I happen to know what angle this is because I recognize those 2 values being on the unit circle. The first thing I might note is that this one is pi sixths or 30 degrees. And so this one must be pi sixths more than pi. So that would be 7/6, so 7 pi sixths. Now, they didn't ask me to figure out what the angle was, but I can, and if I look back at my unit circle, that should match up. Just something to think about. That's one of the special ones. Notice how I'm talking about them in radians, not degrees, just to start getting us used to that.